Okay, so welcome everyone. This session will be about distributed systems and how we can think of our remote teams just like any regular distributed software. So to give you a little bit of backstory, I'm a developer coming from France, and this is my first DevOps. I'm really excited to be here today with you. And I live in Grenoble. That's the city you see at the bottom of the mountains right there. I discovered a few years back that I really enjoyed sharing, learning with other people, like in meetups, during conference, during like pair programming session. And I wanted to try something I just discovered at the time, about like 3 years back now. I wanted to make the switch from being a developer to working in developer relations. But that was kind of difficult at the time because that's a very close circle. There's no many open positions, especially in France. And most of the open positions at the time, that was before COVID, were only in Paris. And as you can see, I love my region. For nothing, I wanted to move on to Paris. And that's ultimately why I decided there was like a good opportunity. And I made the switch to working full remote. Even though I was really skeptical about that, because I'm really someone who enjoy working with others. I really prefer in-person interaction, like being with you today. But yeah, this was a trade-off, and I wanted just to try if I could adapt to working full remote. So first question for you, just to wake up a bit after the keynote. I hope you have taken your coffee, your tea, to get ready to do some exercise. Who's working full remote in this room? Oh, that's quite a few of you. And who in the past years made the switch to working part-time or are still working part-time remotely to this day? That's quite a lot of you. Most of this was caused, I think, to the Corona situation. I have one last question for you. When you made the switch to like from working in person, like in the office, and then switching for the first time working remotely, who had issues the first time? Yeah, quite a lot. And through this talk, I wanted to share a bit of my experience, what I learned from making the switch to full remote, because I felt like I was lucky to make this switch like before I was forced to because of the situation. And I was lucky also to make the switch in a team that was built from the ground up to work full remote. So it was like a great situation to start this experience and to learn a lot from that. And because I'm a developer at core, I prefer talking about tech stuff. I found it really difficult to talk about things like soft skills. I made this talk about distributed systems because that's something I can really speak of, and try to make a parallel to see how it can relate to the way we work as remote teams. My name is Yohan, and I work as a developer advocate at Microsoft. And this is roughly my teams. We're more than 100 of people distributed everywhere on the planet. And it's even more scattered than what you can see on this map because of the clustering. Who in this room works in an international team? That's really so many of you. So I think you can relate to what I will be speaking about in the next slide. So as I said, this talk will be mostly about distributed system. And we'll speak about the kind of issues that you can see and solve in distributed system from these 3 main angles. The first one will be geographic distribution. The second one being scalability. And finally, we'll talk a bit about reliability. And I will have you to make some mental exercise, because I will be talking mostly about tech stuff, as I said. Meaning, you will have to somehow imagine how everything I will be saying about software can be related to some of the situation you might have when working in your team. And don't worry, at some point we'll do checkpoints and we will make some translation from software and machines to humans. First, let's dive into the kind of issues you can have because of the geographic distribution in distributed system. The first big category of issue is the latency. If you want to query some data from any given service, because of the distance, you won't get the data immediately. it will take some time to travel, meaning you will have some latency. Because of this latency, a second kind of issues you might run into is synchronization issue. Because it takes time for the data to travel across the network, at some point you might end up from a service A that want to update another service, and if someone in between tries to get the data, your systems are not fully synchronized at one given time because it takes time. That's normal. There's distance, there's latency, so there might be synchronization issue. And because of synchronization issue, you might run into more difficult category of problems. That's coherency issue, because it takes time to synchronize the different services. If someone tries to query data that might be routed between these two services, something might be incoherent because at some point, synchronization might not be complete. Now, what kind of possible solution do we have to try to overcome this category of issues? The first one, to try to overcome latency, one of the first things you might want to try is try to reduce the distance you have between you and the data you're trying to get. So we have well-known systems to do that. We can use content delivery network, CDN, or we can use some caching system. The general idea is to try to put the data in servers that are replicated as closest as possible as where you want your user to get this data. So basically you reduce the latency, and this means you reduce the distance, and this means you will have lower latency. Another option, depending on the kind of issue you're having, if you try to query multiple times data from service that are from the same location, you may have to pay the cost of latency multiple times. So that's where having some kind of a proxy or a gateway that will do the aggregation of data for you, you might be able to reduce the latency because you will only have to pay the cost of the travel once. So that's another option that you might have depending on what you're trying to fix. Now, if you're trying to think of currency, there's no really good way to make sure the data is coherent in a distributed system. There's only basically one solution, because it's not really a solution, is to centralize the data, meaning everything will have to be put in one central place, which is not really a good thing in a distributed system, but sometimes you have no choice. If you need really strong coherency, that's the only choice you have. I voluntarily took the synchronization solving part for the end because that might be the most complicated one. There's no real way to synchronize data perfectly in a distributed system. So you have some way, for example, if we make a parallel with databases, if you want to make sure there's no issue with people getting access to data that is incoherent, you have a transaction system. You can kinda replicate that in distributed system, meaning if some people are trying to access some data that should be synchronized among different databases, you basically block them the time that you make sure your system is replicated on all the different replicas. That's a very rough explanation of what you can implement in distributed system. That's probably a bit wrong too, because the real implementation is way more difficult than that. But that's the kind of solution you can try to think of. Now, how does this translate to the human world? Because I only speak about software and kind of software solution here. So we can see that the translation could be seen from two different perspectives. One could be you have humans that can try to implement some of these solutions, and on another part you have tools. So that's the two columns you see there. As for trying to implement the equivalent of a caching system or a CDN, but also kind of the same with aggregation to basically reduce the latency to get the data you want to access to. That's basically the closest people you have in your hierarchy, meaning your team lead. If, for example, if you have technical question about, for example, if you're working on an API and you need input or you don't know really how authentication works on a system that's led by a different team, either you try to ask who is in charge of this in the different team, or maybe jump a bit around, or you can just ask your team lead. Maybe he already have the answer, or he can ask that for you. Manager is basically your local proxy for human resource questions. And you may have this role in your company or not. At Microsoft, we have a role that's called program manager. And the role of the program manager's team is basically to work across horizontally many different teams and to help us get the data we want without having to know everyone from every team, because that's basically impossible in big companies. So that's the role of the program manager team. They can do the aggregation if you want input from, you have many different questions from different teams, you don't know who to ask for. They can search, and basically they should already know who are in charge in these different teams, and they can get the data for you, or at least schedule a meeting so you can get access to it without having to lose time yourself, like pinging everyone on Slack and see who can answer your question. In terms of tooling for doing the same thing, when you want basically to broadcast information that might be organization-wide or company-wide, we have some toolings. I've seen that in many companies. That is called Hollands. It's basically at Microsoft, we have that at the CEO organization level every month. It's basically a company update. We have Satya, which is he is our CEO, giving us update for what happens from the business perspective and what we can expect from the next coming month to the whole company. So it's a recording. It's a way to broadcast everything. Something that's really important when you're working remotely also is to make a habit to record every meeting, because I saw many of you are working in international team. We might have different time zone. We might not be up at the same time, so it's sometimes very difficult to have meetings at the same convenient time for everyone. So you need recordings. And besides recording, it's also nice to have sometimes minutes, meaning just keeping track of what was discussed during a meeting, what kind of decision was made, because if you come back, for example, from 3 weeks vacation, you don't want really to go through every meeting recording for the last 3 weeks. You just scan through the minutes and you'll be able to get up to speed very quickly. In terms of aggregation, I don't know if any of you know the website knowhello.com. Yeah, a few people there. That's basically something you have to learn. I've seen that many times with people that are new to remote. When you start working remotely, you have to change your habit of communicating with your coworkers. And because of that, you have to also change your habit of making asynchronous communication the first thing you want to rely on. And because things are by nature asynchronous, using emails or using tools like Slack or Teams, you want to give context. You just don't spawn an email, even if the email was already a meeting you had maybe 15 minutes earlier. You don't know when the person you're sending the email to will be able to read it. Maybe something happened in between. Maybe he had to take care of a family emergency, and he will only be seeing your email a week later. And at this time, he may not remember what was the context. So just put a line of context. If you're asking a question, whether it's on Team or if it's by email, just brief reminder, okay, given this particular context, we were discussing about that. What do you think about? How should I treat this problem, and so on. So even for you, you might get the answer not immediately. It might be a week, 3 weeks later if you went to vacation. You might not even know, if you don't put the context in every email, what the answer was related to which question. Okay, what was my issue initially? Why did I ask that question in the first place? So context is very important here. In terms of centralization, you really don't want to put any people in there. That's the same as with distributed system. You don't want a single point of failure, and you really don't want one person to be that single point of failure. So that means for every information, you need to work with some centralized system at some point. As developers, we use backlogs every day, so we know very well how it works. It allows everyone to track progress of how our development is going. You may want also to have some knowledge base that might be a wiki or any other tooling you want to use in your company to get track of the decision, for example, architecture decision, what's the current objective for this quarter, and so on. And because synchronization is something really difficult in any distributed system, you really want to make sure that you keep the meetings, because that's already only the single way you have in a distributed team to synchronize with everyone at the same time to a minimum. Meaning you make sure to have an objective for this particular meeting. Everyone needs to be on time. That's proper etiquette, especially working remotely, because you never know if someone just right after the meeting will have to go pick the kids at school. That's something I usually have to say a lot. Sorry, I have to leave because my kids will be waiting for me. So start on time, finish on time, and make sure you have an objective and don't have meetings for something that could have been an email in the first place. And of course, because we are humans, we don't work the same way as machines. Since there are so many of you working in international team, you probably have used or seen tools like this all the time. That's like my go-to website for many times when I have to schedule things with other folks from my team. You need to work across time zone. But sometimes time zones are good. We'll see that later. Ultimately, as I said before, synchronous communication is difficult. So you want really to rely on any kind of asynchronous communication first and make sure there's retained content about what you're trying to achieve and what you're doing currently, because otherwise that's the same as not existing at all. Are you still there? Okay, now let's switch back to distributed system on a different category of issues. We'll talk about scalability. So, when you want to scale, if at some point you have a service, there's too many requests at the same time, if it was not made to accommodate for that many requests, you get overload, your service crash, everything stops working. If your system starts to get more complex over time, you may end up in a situation when the communication between your different services, especially if you're using microservices, becomes difficult because you can't really keep track of the data flow between the different services to service communication. And that's a really difficult problem to solve. So what are the possible solutions to accommodate these issues? You probably all have seen this kind of graphics before. To accommodate load issue, if you want to scale, you have really two main ways to do that. You can do vertical scaling. For machine, it means adding more powerful CPU, adding more memory to that, so it can accommodate the load. But in distributed system, we tend to do more horizontal scaling, meaning you distribute the load among different replicas of the same service you want to scale up. And because of that, it's really convenient oftentimes to move from a monolithic architecture to using microservices. And just as a kind of fun fact, microservices were not only designed at their core to make sure your service scale well, it was also made as a tool to solve issues that people were having because of too big teams. So it was also used from the beginning to solve human issues. Microservices both solve scalability issues and human issues. When you're talking about data, if you have too many data to store in a database, you will need to think at some point of sharding. Sharding is basically you need to divide the quantity of data you put in one given database. You just have to select on which criteria you will shard, meaning you will split your data. That can be for example, put all the data related to some particular user at the same place. It can be a criteria can be the different kind of data. For example, you put all the picture profile in one database, all the address or personal information in another database. Or that can be also by geographical location. You can put, for example, all your Belgium user in a database or your German user in another database and so on. So you have many different ways to split the load. When you're trying to fix the service-to-service communication issue, especially if you're working with microservices, you might want to try to decouple the service as much as possible. That's also why it's a good practice to usually avoid having, for example, one database that is used by many services because it tends to make the number of requests between these different services grow. And basically, you want to make each service as autonomous as possible. That's why you have one service with one database per microservice. You reduce the load, each service is decoupled, meaning there's no useless communication between them. Now, if you have some huge amounts of data and you want to try to make sense out of that, we're talking a bit about big data problems in there. There's this very well-known algorithm that's called MapReduce that is used that. Basically, you take your pool of raw data, you try to clean it up. That's the mapping part where you make sense and you just remove the data that's useless to that. And then basically, the reduce part is like trying to aggregate some part of data. We using some smaller cluster. You do that reduce part many times. And at the end, you extract the essential information you wanted in the first place. Now, how this translates again to the human world? In terms of scaling, nothing new. If you need to work a bit faster, you need at some point more people. But we are developers. We know that adding more developers to a late project make the project even more late. So you need to think of which kind of new teams you might want to create, maybe split existing teams, maybe create new teams. And keeping in mind the microservice situation, you want really to keep your teams as small as possible. I think it was Amazon at some point who coined the term pizza team, basically trying to not add more people to a team than what you can share a pizza with. So in practical terms, that means 5 to 7 people in a team is kind of good number, sweet spot. In terms of sharding, that's where you really want each team to be as focused as possible on a given topic. You decide to split, you can just choose on which criteria, but you give them a specialty. And usually, as for toolings, there's a framework that's the OKR frameworks, objective and key results. Who knows about OKRs in that room? Okay, quite a few people. I won't have time to explain OKRs in details, but basically it's a framework for management for determining the objective going from the top down of your company, meaning the CEO. Basically, you define 2 to 3 main objectives you want to achieve for a specific period of time, usually a quarter. You define the metrics, 2 to 3 metrics for each objective to know how to measure if the objective was successful or not. And you decline this objective one level down each time, meaning you have to refine for each team, starting from the CEO up to the bottom teams. And that's how it works roughly. So I encourage you to look at that because it really helps when you're trying to scale an objective from the top of the company. It was made, I think it was invented by Intel a few years back, and it's already used a lot in tech companies nowadays. In terms of decoupling, it's exactly the same as what you're trying to achieve with software. You want to give each team as much as autonomy as possible. Meaning if for each decision you have to make in the team, whether it's a technical or just managerial decision, you have to go up 3 levels to wait for a decision. It takes forever. And basically, if you give as much autonomy as possible to your given teams, you make them faster. That's how it works with services, and that's also how it works with humans. And when you want to get a lot of data, if you want to get feedback from all of the people from the field, usually that's the role of the manager. If you have a good manager, basically he will take your feedback and explain it, take the feedback from the teams, put it up to a level to his own manager, and so on up to the CEO. So good decision can be made from the hierarchy perspective. You have toolings to do that also too. If you want to get a good amount of feedback from anywhere in your company, you can have Ask Me Anything session. We have that from each organization in Microsoft. Every time a month, we have our CTO who organize an Ask Me Anything session, so meaning everyone in the company can ask difficult questions most often. And that's also why having minutes when you're having meetings or decision, and also doing some debrief when something when's bad or when's good in a meeting is important, because when it's time to get the important information back and to make this information seen in the company, you can't expect like your manager to be at every meeting, so he most likely will scan through every minute, aggregate that data, and basically doing a match produce up to the CEO. Now talking about reliability. When you're trying to implement high availability in your distributed system, you want to be you want your system to be available out all the time, always working. If one service goes down, you want the system to continue working. If one service goes down, and maybe at some point a request was made to maybe update some data, you might encounter data loss. And you need to have a way, because you're not there physically with your servers, you need to have a way to monitor if everything's fine in your system, but most importantly, if there's something that might be wrong or that might go wrong with your system. So how do you implement that? For high availability perspective, the first thing you want to do is basically replicate some of your services. So you can do load balancing. That's also a way to scale. You just take the load, give it some part to one instance, some other part of the load to a different instance. And also you need to monitor if at some point one given instance of your service goes down. So you can redirect like the traffic to the still working instance. So you need to implement a failover strategy. That's where we can talk a bit about chaos engineering. Chaos engineering was like a practice that was coined by Netflix. Basically, the idea is you make some of your services fail on purpose regularly, just to make sure your failover strategy works well. And you do that like during your regular workday. And because you do that like you know when your system will go down, you're ready also to fix that in case something don't work as expected. Meaning there's less chance that it happens on the weekend when nobody's working and you have like to get all your on-calls developer wake up at 3 a.m. in the morning. When we're thinking of data loss, first thing we can put in place, of course, is backup. You want to have backup everywhere to make sure if at some point there's a risk of storage loss, you have a replica. If you have critical data, you want to make sure that's persisted at some point in your system. You might want to use like an intermediate storage resource to do that. So that's called a queue. Basically, I want to make sure that data is delivered. For example, in the voting system, I want to make sure that every vote is persisted. You put it in a queue, and this queue will persist the data temporarily. It will make the call to the service and will only remove the data from the queue when it received the acknowledgement from the service that, okay, this data has been persisted. You can move on to the next one. In case of reading issues, basically you try to request some data and you never get the answer. That happens all the time when using your cell phone, for example. You just wait some time and retry it. And finally, to implement monitoring, there's many ways to do that. And like when the first step to make sure like you have a basic monitoring system, the first thing you usually implement is a kind of health check mechanism. Meaning you have all your services and you put them to tell like regularly, maybe every minute, every hour, depending on what you want to get, to report to a dashboard and say, hey, I'm alive. In case you don't hear like from a given services, you might assume something's not really right if you can't ping to the regular health check service. And now, to be able to have a better understanding of your system, the first thing you want to have is to define measures. You want to get an insight of what your system is doing, what are your different services doing. From these measures, you extract metrics. That might be like average CPU usage for a given service. That might be the number of requests for every second. And depending on these metrics, you define alerts. Alerts are like a threshold. You say, maybe if you get more than 30% of errors rate every minute on every request, something might be wrong and we need to have a look into that. So you want to know when something is wrong in your system and you want to know it quickly. How does this translate to the human world? As for implementing load balancing, having a good failover strategy, having backups, most of that relies on your teammates. But for it to work nicely, you need first to make sure that the knowledge is shared as most as possible in the team. That's why also you can rely on time zone. As I said, it's difficult to work in an international team because of time zone, but sometimes there's also benefits to that. For example, if you have on-calls in your team, who have on-calls, regular on-calls for their team? Quite a few of you. If you are working in an international team, that might be easier to set up for everyone to only be on call during the regular work hour to avoid having to wake up, as I said, at 3 hours in the morning, like on a Saturday, when you know your kids will be annoying 4 hours later. So basically, it can be also an asset, but you have to make sure that the knowledge is shared among everyone. That means you need to write documentation. You need to do a lot of pair programming. And I've often hear a lot, but because we're remote, it's difficult to do pair programming. That's not true. Today, we have a lot of tools that are most often embedded directly in our IDs to do that. You need to do sharing sessions in your team regularly, and you need to have regular setup for that, regular schedule, because that's not something that comes naturally most of the time. You need to really have a knowledge base of written content to make sure every decision that was made in the team is written somewhere. So you can know what that particular framework was decided to be used, what was wrong at the time with the other possibilities. Something that was also nice that I discovered in my previous company was handover emails. That means before someone goes for a few days of vacation, you don't really want to have their teammates just discover when something goes wrong or because the work they were in progress before going to vacation became suddenly very important and everyone needs to take back what your coworkers was doing and nobody basically had a clue what he was doing just before going to vacation and he's at the opposite side of the earth. He won't be there with a network until 3 weeks and basically every week is So handover emails, it's just a simple, before going back to vacation, you just make a quick recap what kind of features you were working on, where's the documentation in case something needs to take over your work, and who might answer if anyone has a question about anything you have knowledge on, and you might be the leader for this particular set of features. So just a handover email before going to vacation and makes everyone safer in the team because they know if they have to take over, they will know the context. As for implementing queues, we use that every day as developers using a backlog. We also have some kind of to-do list sometimes. I use that every day as my regular tool to make sure I don't forget to implement something or to do something I needed to do. And something you really have to learn, and I learned that the hard way when I started to work remotely, is you don't have to take it personally if sometimes you send a message to a given person, whether it's an email, whether it's a message on a chat application, if that person don't reply it to you, or maybe forgot. I've seen so many times people just get angry, oh, he never answered to my email, he must not consider me, or blah, blah, blah. Things can happen. You never know if that's what happens to these people. And I really came to this realization when I had many managers just told me, okay, I'm coming back from 3 weeks vacation. I won't read any of your emails. If you send something important during I was then there, basically just rescind that, because as soon as I got back, I have like this list of 10,000 emails. I won't go through that. I just select all, delete that. I was okay. If anything important comes up, people will just ask again. Okay, so if you don't get an answer to like a question or an email or anything you said, you might want to try different channels. Sometimes people prefer to work with emails. Some people never look at their emails and prefer to work with chat system. Just try different channels and retry. That's like the normal thing. As for implementing health check, that's mainly the role of the manager, but also you as a teammate within a team to make sure that everyone in the team is fine. It's gonna become difficult because like you're not having coffee maybe every morning, you don't see your coworkers directly outside of meetings, so that might be difficult to know if something, if a coworker feels bad or if something happened and he needs maybe some support. So it's really important to implement some mechanisms, some tools to make sure everyone feel good and to detect issues if someone started to feel very isolated. So you can have, in my previous team, we had at some point status report for every week. Basically, we put 3 very short bullet points about what we were working on, and if something happened that was fun, but also if we had some troubles we wanted like to surface. That might be just personal trouble to know, okay, maybe he's not the best person you want to stress, and right now maybe I can ask another coworker. So just give an update of the situation. It might be just a regular ping, like ping your coworkers every morning. Hey, how are you today? Just talk about the weekend, just like you will do like if you were in person next to the coffee machine. Might be also some anonymous survey if you want like to get real feedback. Sometimes as soon as you have written content with your name on it, people might be reluctant to give honest feedback. So that's why having a way to report things anonymously might also be important, like honest survey about how your team is doing, what's your feeling of your manager. So having some kind of surveys is also important to have like a honest monitoring system. And speaking of monitoring, monitoring like your teams as a whole, that's mainly the role of the leadership team. But I don't mean that like in a surveillance way. That's not really something you want to implement, because that's not something you want to have. The most important thing in there is to have transparency. Of course, you need to define objective. You need to know how this objective will be measured. Sometimes it's really nice to have a shared dashboard so you can know where you're at in your team, like in the progress of your different objectives. But it's also important to know where other teams you might be relying on. For example, if you're working on the front-end part of an application and you need to rely on the API part that's developed by another team, if you can't access their dashboard, you might be uncertain about their progress. You might be stressful because you need to rely on their API to make progress on your own objective. So everything is about transparency there. It's not about surveillance. It's about sharing a common objectives, and every decision, every progress that's made through your company should be transparent as possible. Because if you know that the backend team might be late, there might be issues, maybe at some point you can try to help them, because you won't be able to move forward if they are not progressing as well. Of course, there's more to that. We can talk about security. We can talk about persistence. We can talk about updates, openness, and all kinds of other issues that you might have in distributed system. But you really need to think that's okay. We're human after all, and maybe like making like a parallel with how distributed software architecture works sometimes might help you like think of a more pragmatical solution you might try or want to try to implement in your team. But it's not always possible to do that, and we have to keep track that's something really essential when you start to work remotely, because everything's distant, because you don't have like eye-to-eye communication with your coworkers directly. You have this tendency to like overwork yourself and to only exist by your output. You just become like a machine basically in the system. We're human, meaning we need to have positive things to keep working, not just only like food, sleep, and code. We need to tell also when something's wrong. That's really important because if you don't tell that, that's really difficult for your coworkers, for your manager to know that. We need to share status, as I said. Maybe sometimes it's just a fun fact, like have everyone in your team share one fun thing that happened to them during the week. Might be help to make everything better, might help also team building. You can do team building session just like you can do like a session at the bowling with everyone. You can do remote activities like playing online games together, having cooking session, having like just your regular coffee, but remotely. We call that remote coffee in our team, and so on. And really don't forget to take breaks, because everyone I see that made a switch to working remotely, the first thing that you forgot is basically just take break. And at the end of the day, you don't know why, but you just feel exhausted. And if it goes on for a long time, you really feel that. So just think of break, just think of keeping your like human connection with everyone. Even if you don't see the people, it's really important because human is a social animal, and we need to keep our social connection going, even though you don't see the other people's every day. So thank you for attending this session. I think we have some time for the questions, if there's any, and you have the link to get the slides if you want. Yeah, I don't know if we have like a way to get questions. Yeah, if anyone wants to ask a question, just raise your hand and shout very loud. If not, that's good also. Oh yeah, one question.
Outdated and it's difficult to keep track. How are you handling that? How are you maintaining your wikis? Is any way to automate that or make it more automatic or updating it?
Yeah, so the question was, I was talking about knowledge base and wiki specifically, and the question was, is there a way to automate like the updating of data to make sure it's not outdated at some point? So I don't think there's a way to automate that, but you can have strategy to make sure that there's no stored data. In my previous company, we had to make sure that every team had its own wikis. You could access the one from the global the company, but basically you have a subset of the wiki that's managed by your own team. And you need to make sure that, like for example, the onboarding was always up to date. If there's any newcomers that need to go in the team, every page you need to track like any kind of architectural decision you made for the team should be traced in that wiki. So that's not something you kind of update. But if there's new decision, of course, you add them to the wikis. And basically, you have something that's updated naturally, regularly. Like, for example, how you need to work with the project, like the day-to-day, the schedule of the team. For example, if you're an agile team, your like own team manifesto and so on. So it's not a perfect way to make sure there's no stored data, but you basically split the responsibility given a focus on each part of the wiki by team. So you make sure each team should only update their own related parts, but any team can access the data from anyone in the company. Yeah?
What if your team has, let's say, a very bad practice and didn't have a wiki before? What is your best advice to start with having a wiki? Do you start with each new information? Or are you taking, for example, just break of the regular work and do a couple of weeks just doing all the past decisions and tools in the wiki? So yeah, how do you start with the wiki if you had the bad practice for not having them before?
Okay, so the question is how do you start implementing a wiki, basically a centralized knowledge base in your company, if you didn't have that practice before? So that's really a tough, difficult question, but we had to implement that on our team because when I joined, it was like a remote team in the mindset because it was thought for that, but we have no centralized way. And there's no, I think, good solution that can work for everyone, but the way it worked for us is basically everyone who at some point an issue because, for example, taking personally, I don't know when I joined how to like install and set up the VPN. That's something that might be helpful for any other. So when you have this issue, okay, it's not anywhere. So okay, we create a document. We say that no, we use that tool in our team, and every time someone encounters that issue, that goes very fast at the beginning, you just add that entry. So I put the documentation myself. Once I found out how to set up the VPN, someone used that at some point. At some point, it was outdated because the VPN was changed. And the first people who was unlucky to come into the documentation and see that, okay, it's not up to date. So he searched from how to set up, what's the new way to set up the VPN, and updated the doc. So that's basically one way to build that. It comes naturally because you all have issues, you all have questions that are not everywhere. And if you start to like force a bit people in your team to take this habit of, okay, if there's something you're searching for, a question, and it's not answered in any written documentation, write it yourself. And basically the knowledge base grows really quickly going from that. If you already have like, for example, a decision that were made in the past that were not documented, maybe that's difficult. But at some point, the question will arise again. Okay, someone will have to dig. Why did we use like this particular framework in the past? Who the hell decided to use AngularJS like at some point? It's really helpful. And maybe so you will have to dig to answer that question. And maybe there's some legacy. Maybe there was something that was not implemented in other frameworks at the time. So you will write the documentation from that. So that's basically a way to naturally populate your knowledge base going from 0 to having something useful from your team. Other questions? If you have any other question at some point, you can also ping me anytime on Twitter, or just go by. We have a stand, Microsoft stand, GitHub stand. In there, you might catch me in person. I might come to the stand from time to time. So thank you, everyone.